Welcome to Section 5.2, Multidimensional Arrays. In this lesson, you will learn how C stores tables of rows and columns. Let's begin. Welcome back. A one-dimensional array stores a list, but a lot of real data is not a list. It is a table with rows and columns. Think of a gradebook, a game board, or an image. In this lesson, you will learn how C stores tables using two-dimensional arrays. This is the plan for this video. First, you will see why a single list is not enough. A two-dimensional array stores a grid of rows and columns, like a gradebook or a game board. Next, you will learn how to declare a two-dimensional array with a row size and a column size, and how to reach any cell using its row and column index. Then you will set up a grid with nested braces, and walk through every cell using nested loops, one row at a time. After that, we look at the memory layout. A two-dimensional array is really one flat block of memory, stored one full row after another. This is called row major order. Finally, you will learn how to pass a two-dimensional array to a function, which needs the column count, and how to avoid the common mistake of swapping the two indices. A one-dimensional array stores a list, a row of scores, temperatures, or counts, but a lot of real data is a table, not a list. A gradebook has rows of students and columns of assignments. A game board has rows and columns of cells. And an image has rows and columns of pixels. A single flat array of 30 scores cannot keep that row and column structure, so C gives you multidimensional arrays. These are arrays of arrays. A two-dimensional array is declared with two sizes in brackets, one for rows, one for columns. We write int grid, square brackets 3, square brackets 4. The first bracket 3 is the number of rows. The second bracket 4 is the number of columns. That is 12 int values in total. A two-dimensional array is organized as rows and columns. Each element is reached by two indices, the row and the column. And just like a one-dimensional array, if you do not initialize it, all 12 slots hold garbage until you assign to them. Each element in a two-dimensional array has a row index and a column index. Both start at 0. Look at grid bracket 0 bracket 2. That is row 0, column 2, the third element of the first row. Its value is 3. And grid bracket 2 bracket 3 is row 2, column 3, the last element of the last row. Its value is 12. Always remember the first index is the row and the second index is the column. The output confirms it. Grid 02 is 3 and grid 23 is 12. This is the logical grid. Columns go left to right, 0, 1, 2, 3. Rows go top to bottom, 0, 1, 2. We will build it one row at a time. Row 0, 4 cells. Grid 00 is 1, grid 01 is 2, grid 02 is 3, grid 03 is 4. Row 1 right below it. Grid 10 is 5, up to grid 13 is 8. Row 2. Grid 20 is 9, up to grid 23 is 12. The first index picks the row. The second index picks the column. You can initialize a two-dimensional array right where you declare it, using nested braces. The first group 1, 2, 3, 4 fills row 0. The second group fills row 1. The third group fills row 2. Each inner pair of braces fills one row. Notice how the shape of the code matches the shape of the grid. You can see the rows directly in the source. Partial initialization works just like it does for one-dimensional arrays. Any value you leave out becomes 0. Here row 0 gets 1 and 2 in the first two columns, and the rest are 0. Row 1 gets 5 in the first column, and the rest are 0. Row 2 was not listed at all, so every element is 0. And if you want the whole array set to 0, just write open brace, 0, close brace. Give one explicit 0, and C fills everything else with 0. This is a clean way to start with a blank grid. The standard way to process every element in a two-dimensional array is a nested for loop. The outer loop runs over the rows. Its variable r takes values 0, 1, 2, 1 per row. The inner loop runs over the columns. Its variable c takes values 0, 1, 2, 3, 1 per column. The expression grid bracket r bracket c reaches each element in turn. After each row's columns are printed, printf of \n starts a new line. The output is the grid, printed row by row. The nested loop visits every cell. The outer loop picks the row. The inner loop walks the columns. Watch the green marker move. Row 0, column 0, grid 0, 0. Column 1, grid 0, 1. Column 2, grid 0, 2. Column 3, grid 0, 3, row 0 is done. The outer loop moves to row 1, column 0, grid 1, 0. Column 1, grid 1, 1. Column 2, grid 1, 2. Column 3, grid 1, 3, row 1 is done. The outer loop moves to row 2, column 0, grid 2, 0. Column 1, grid 2, 1. Column 2, grid 2, 2. Column 3, grid 2, 3. Every cell has been visited in row order. You picture a two-dimensional array as a grid, 3 rows and 4 columns, but memory is one flat line, so C has to lay the grid out in a single row. C uses row major order. Row 0 goes first. Values 1, 2, 3, 4 at offsets 0, 1, 2, 3. Then row 1 right after it. Values 5, 6, 7, 8 at offsets 4, 5, 6, 7. Then row 2. Values 9, 10, 11, 12 at offsets 8, 9, 10, 11. One continuous block. So the element grid RC sits at offset R times 4 plus C, the number of columns, 4, is the multiplier. Why does row major order matter? First, let's state it clearly. For an array with R rows and C columns, element A at row R, column C, sits at offset R times C plus C from the base. Elements of the same row are stored one after another. This explains sizeoff. Sizeoff of grid is 3 times 4 times the size of an int, which is 48 bytes. The array is one flat block. The grid shape is really kept up by the indexing syntax. It also affects speed. When you iterate row by row, changing the column index in the inner loop, you touch memory in order, so it is much faster for large arrays. The practical rule is simple. Put the column index in the inner loop. A two-dimensional array in C is literally an array of arrays. The declaration int grid 34 creates an array of 3 elements, where each element is itself an array of 4 ints. You can see this with sizeoff. Sizeoff of grid is the whole thing, 48 bytes. Sizeoff of grid at 0 is one row, 16 bytes, that is 4 ints. Sizeoff of grid at 0 is one element, 4 bytes. Because of this, grid at 1 is a valid expression on its own. It refers to the entire second row as a one-dimensional array of 4 elements. Passing a two-dimensional array to a function needs the number of columns in the parameter. The number of rows can be left out. Look at the parameter, int grid, empty bracket, bracket calls. The empty first bracket means the number of rows is unspecified, so you pass it as a separate int rows parameter. Why is the column count required? Because of row major order. To find grid RC, the compiler computes the offset R times COLS plus C without knowing calls. It cannot do this. Using a hash-defined constant for COLS keeps the size in one place. Let's look at a practical example. A gradebook where rows are students and columns are assignments. We want each student's total score. For each student, that is each row, the inner loop sums across all the assignments, that is the columns. Notice that total is reset to 0 at the start of each row. This is the accumulator pattern, applied once per student. The output shows each student's total, one line per student. Let's read the output. The gradebook at the top holds 4 scores per student, and the inner loop adds up that student's assignment scores. 65 plus 70 plus 58 plus 60 is 253, and so on down the rows. The function prints one line per student. Student 1 totals 253, student 2 275, student 3 225, student 4 275. Each number is the sum of that student's scores across all the assignments. 4 students in, 4 totals out. There are 2 common mistakes to watch for. First, swapping the row and column indices. Suppose grid is 3 rows by 5 columns. Writing grid bracket 4 bracket 2 is a bug because row index 4 is out of bounds. The valid rows are 0 through 2. This writes past the end of the array, which is undefined behavior. Always think first index is the row, second index is the column. Second, do not leave out the column size in a function parameter. Writing int grid, empty bracket is a compiler error. It says array has incomplete element type. The compiler needs the column count to compute memory offsets. Let's recap. A two-dimensional array is declared with 2 sizes in brackets. Int grid 34 is 3 rows and 4 columns. You access elements with 2 0-based indices, grid row call, where the first index is the row and the second is the column. The standard traversal uses a nested loop, outer for rows and inner for columns. In memory, C uses row major order, so grid RC sits at offset R times calls plus C. A two-dimensional array is literally an array of arrays, so grid at 1 is a whole row. And passing a two-dimensional array to a function needs the column count in the parameter. Next, C has a special kind of array, an array of char values that represents text. In the next section, you will learn how C stores strings as character arrays.